What is quantum computing? Before we can talk about quantum computers, we need to talk about classical ones. Meet the transistor. Hello! A transistor is a very fancy switch, so it can either be in the on or off position. We can say that on represents the number 1 and off represents the number 0. This is the idea of binary. Each 1 or 0 is something called a bit. Now, a bit may be a transistor, or it may be some kind of on or off switch in a magnetic drive, like a hard drive. By connecting these transistors together, we can do lots of different kinds of stuff, like add or multiply numbers. We can make colors or shapes or play your favorite video game. Now, a quantum computer also uses bits, but it's a little bit different than a classical computer. In a classical computer, it can either be 1 or 0. But in a quantum computer, the bit is going to be in the states 1 and 0 at the same time. And that's due to a principle called superposition. I explained that in other videos. Now, what are the advantages of a quantum computer over a classical one? Well, let's use the example of prime factorizations. That is finding all of the prime numbers that make up another number. To remind everybody what a prime number is a number whose factors are only 1 in itself. And by factors, I mean numbers which are integers, so not 1.357 or something like that. So take the number 7. There are no two integers below the number 7 when multiplied together will make the number 7. So I cannot say multiply 2 times 3 or 2 times 4 or 2 times 5, etc. to make 7. But let's take the number 6. Now you can make 6 by multiplying 2 times 3. So that means 6 is not a prime number. Prime factors are prime numbers that make up another number. So the prime factors of 6 are 2 and 3. You can do this with all sorts of numbers like 25, or you can do it with 36 or 101. A common encryption technique is to have a very, very, very large number, which is composed of just two very large prime numbers. The technique works like this. The bank and I are going to agree on one really, really big number. Now, the data is going to be encrypted by using the prime numbers of this really, really large number. So I will send the number to the bank. The bank says, I know this number. I know its primes. And all of the data information that I send needs these two prime numbers to decrypt the data. So for a classical computer, this is a very difficult task because it has to search all of the different prime numbers that could make up this big number, and it has to do them kind of one at a time. It has to test it. But for a quantum computer, it's different. You see, a quantum computer, because its bits are in these superpositional states, it's essentially able to search all of the possible prime numbers that make up this big number all at once. And that's a lot faster. So does this mean that a quantum computer is going to replace your classical computer? That's very unlikely. And the reason is because classical computers are great at some things and quantum computers are great at others. So although a quantum computer can do prime factorization really well, for example, what it doesn't do so well is add two numbers together, like 2 plus 2. Not very good at that. Well, a classical computer does those stuff really, really well. So in the future, what you might imagine is a computer which is classical and quantum together. So you'll have a quantum component and a classical component, and sometimes you'll do stuff for the quantum, and sometimes you'll do stuff for the classical. Well, I hope you've learned something today. Please, if you like my content, please like and subscribe, and I'll see you guys later. Thank you very much. Bye-bye.